morning, everyone. So, thank you for having me here. And yeah, my topic is evolution of wireless in general. So, the agenda which I prepared is like this. So, do we need wireless at all or not? The second topic is evolution from the technology point of view. The next one is evolution from the management point of view, architecture point of view, security point of view. Evolution from the wireless design. That's also something which has changed over the decades. And some wrap-up, like mandatory features and what you should have. So the first thing is a small video, which I would like to show you. That's a 2 years old video. Look at that. Look at those fingers. It's broken. Doesn't work. This doesn't work either. It's useless. Maybe, maybe my finger is not working. Maybe the tablet works, but the finger may be broken. No. The finger works. The finger works. Okay. So let's return to something which works. And yeah, happy children. Okay. That's from YouTube. That's 2 years old video. If you think about that, there is no way how you can connect tablet to wire. Okay? Those children now are approaching the kindergarten and primary schools. They do expect wireless is everywhere. Okay? I was with my children, with my daughter, and she asked, "Oh yeah, I can send you to you, no problem, the message." I said, there's no Wi-Fi here. What do you mean by no Wi-Fi? That's tablet. It works. No. The Wi-Fi is mandatory today. The wireless is mandatory today. So the wireless and Wi-Fi in general, it's a must. There is no way how you can connect, or there is, but that makes no sense to connect tablet or smartphone to the wire, right? Even the new notebooks and netbooks, if you buy them, they do not have Ethernet at all. Or if they have, that's very unfriendly, unusable, not comfortable to use it. So wireless is important. If you think about the trend, Internet of Things, if you think about that, set-top box, TV, that's what general is connected today to the Internet. The funny thing is the scale, for example. So you can have a scale, so you step on the scale, it will show you what is your weight. Good. It just updates this information on your profile. So what happened to me is we have a cleaning lady, especially for the Christmas time and those things. So the cleaning lady was cleaning my house, and she stepped on the scale. And the scale sent me a message. There is a new profile. So what is the name? What is the age? I will create a profile for that. So that is wireless connected. The big thing is smart city. Now very, very attractive topic. So you can have in the city a lot of things which are wirelessly connected. Like you can pay for the parking. That's wireless, usually. You can see what is happening. Like, okay, don't go that way. There's a traffic jam. Use another. So that's a smart city. Again, Internet of Things. If you look at the statistics, what I found is from Forbes, Internet of Things by numbers. So in 2008, so that's a long time ago, there were more things connected to Internet than people. So Internet of Things already happened. Okay? In 2020, that's expected that 250,000 of vehicles, cars, will be connected. I believe it will be much quicker, that number. In 2015, the wearable devices, this Fitbit and Apple Watches and all those things, had grown in 223%. Having kitchen connected to the internet, it's expected that you will save 15% of beverages and food. So you have the information what is in your kitchen, so you don't need to buy it again. You know what you should use. In 2016, almost 5 billion things we expect to be connected, or they expect. That's from Forbes. So, yep, Internet of Things is happening, and the wireless is the technology for that. So how it started, evolution from the technology point of view. In 1997, almost 20 years ago, okay, 802.11 was established, was founded. And what I like is, if you look at the rate, and the rate which was available, it was 1 or 2 megabits at that time, 1997. It was using the direct sequence spectrum or frequency hopping. So now that's used with Bluetooth, for example. So 2 years later, there was something which was called high rate. Okay, 11 megabits. Cool, funny, right? I agree. 1999, 11B on 2.4 gigahertz. And the same year, it was 11A founded, which is on 5 gigahertz, 54 megabits. Wow. 2003, 54 megabits on 2.4 gigahertz, the G standard. If you look at that, this was called very high rate. Okay? In 2007, a lot of things happened from the wireless point of view. There was a new IEEE standard established with 8 amendments just combined together. So it is the A, B, G, some security, some availability thing, some things which are for Japan, for example. So that happened in 2007. If you look at 2009, this is called high throughput when 11N was established. So the standard does allow to go up to 600 megabits. That's the standard, that's good. Unfortunately, the reality is a little bit different. So there are no products which are able to go over 450 now. But it is on both bands, on 2.4 and on 5 gigahertz, so that's also some improvement here, very high and very good improvement. In 2007, it was a draft, so that's also some important thing. You can find the products which are draft only. They do not make it to be certified for full 11N. In 2012, again, the whole 802.11 was redesigned. And there's a lot of amendments which were done, and they were combined together. So that's like enterprise voice and those things. And the funny thing is that there was something like several hundred pages of standards which were dropped. There was standard which was designed, but no one implemented it. Okay, so just drop it. So 2012, 2013, 3 years ago now, the 11AC was established. So very high throughput. Okay, the speed goes to almost 7 gigabits per second by theory, by the link speed. Of course, that's not real. So if you use 160 megahertz channel, if you use 8 spatial streams. The future, 2019, 11AX is expected to be certified. Okay, data rate is expected to go to 14 gigabits per second. So that's not far future. If you look at the date today, it's not so far. If you look at something which is also wireless, which is not Wi-Fi, this one is called WiGig or wireless USB. It is going on 60 gigahertz channel, on 60 60 gigahertz frequency, the data rate over 6.5 gigabits per second. So this is 2011. That's already there. It's already available from the standard point of view. And this can be a future if you think about the channels which we are running out. Even on 2.4, it's that. But on 5 gigahertz, if you think about the channels which we have, if you think about the channel width, this can be the way to go. In 2017, it's expected to have this standard better evolved to something like 20 to 40 gigabits per second. The cool thing on 60 gigahertz is that it does not go through walls. Okay, so the big issue today is if you put the access point here, you will have a signal in that room and that room. Okay, so if you do a huge transmission here, it will influence another rooms. It will not happen in 60 gigahertz channel because the signal is not able to go to concrete so good as the standard on 5 gigahertz or on 2.4. So this can be a future for wireless also. There is something which is also interesting as the TV is going to be digitalized. Okay? So as the terrestrial is going to be digital, so the analog TV the space is going to be available. So there is a standard which allows to use these frequencies. Okay, once upon a time and a little bit of the future. So the evolution from the standard and technology point of view. If you look at the actual status which we have, there is a session just talking about 11AC. Okay, so the technical session is available today. So just a few headlines here. So 11AC as a standard is now ratified, no problem at all, it's available. But the products were not able to make all the features at the same time at the beginning. So we have 11AC Wave 1 available. We have 11AC Wave 2 available. So just to comparison with 11N and with 11AC as a specification, what it allows and what it doesn't. So the main benefit of AC Wave 2 is something which is called multi-user MIMO. Or another benefit is the channel width. With the channel width, if you use more channel, you can get better speed. The modulation is the same. I have a slide for that, talking about modulation regarding spatial streams, so how much traffic you can get through that. So it's also improved. So that's just the comparison of 11AC Wave 1 and the Wave 2, and the specification itself. Yep. So just to understand what it is from the technology point of view, from the modulation point of view, just think that you can distinguish the top right quadrant or the top right picture. You can distinguish 16 different options at the same time. Okay? So if one of those black dots will blink, you can see which one was it, and you can understand what was the signal, what was the symbol which you tried to transfer. So if you go to better modulation, different technique, you have 64 of these dots. And what is available now, it's 11AC, it's 256. So the first point of view, good, I can transfer more data at the same time, absolutely. But I cannot transfer that data for very far, because if the signal goes lower, you are not able to distinguish which of those dots it was. And if you have some noise, you can see that not here, but you can see it here. That's wrong. You have no idea what it was. Was it this one, or this one, or this one? Okay? So that's the modulation, how it works in general. Okay? So what it means for the business, for the reality is that the new standard 11AC will give you better throughput if you are close to the access point. If you are far, there is no benefit from the modulation point of view, because you will go from this one to this one. I don't understand that speed, so let's fall back. So that's the modulation. The next thing which comes with the new wave, it's 160 megahertz channel, or 80 plus 80. That's here, 80 plus 80 megahertz channel. So if you look at channels which we have, you are using a lot of them. Yep, that's the way. That's what the 11AC gives you. More data through the air. As I said, there is a whole technical session regarding 11AC. So if you compare 11N, if you have access point here, this is the speed which you can get at this area. If you have 11AC with 40 megahertz channel, you are not getting better coverage. But you are getting better speed if you are close to the access point. Okay, so that's the benefit, definitely. And if you have higher or wider channel, which is not available everywhere, but we are lucky in this, let's say, part of the world that the walls are thick. If the walls are thick, the signal cannot go through, so you can use more channels here because they will not influence the next room so much. So if you are using 80 megahertz channel, you can get better coverage, which you usually don't need, but better speed. So that's just explanation what 11AC gives you, why to go with 11AC. One thing which is absolutely great from marketing point of view and from the technical point of view, if you understand it a little, it's beamforming. So there are companies which are explaining how beamforming works. So in general, you can, instead of transmitting to everyone, you transmit to one particular user, and you somehow beamform the beam, the signal. The bad thing here is that there are many standards for that. So both client and access point must use the same standard to be able to use it, which was not in the past available, because usually you don't have the same NIC card and the same vendor on the access point. In 11AC, it is standardized. So there is a standard for that. From those 4 options which we had on the market, there is one which is mandatory for use. So now the beamforming will work. Another benefit of Wave 2 is that the access point can talk to more devices at the same time. That's called multi-user MIMO. Okay? So just to have it an example, you have 4 antennas here. So 2 antennas are talking to, an example, or let's say abbreviation, 2 antennas are talking to this guy, 1 antenna to this guy, and 1 antenna to this guy. That's a cool feature coming with 11AC Wave 2. Okay? So you can transfer more data at the same time. So if you are considering to deploy 11AC Wave 2, and you don't have 11AC at all, you should definitely think about site survey. You should, because the coverage will be different. Okay? You should think about infrastructure. If you think about 11AC, based on the standard, it can go to 1 gigabit speed very easily from the access point. So the question is, do you have a cabling available for the access point? Okay? So the cabling, PoE, power over Ethernet. All access points are usually powered from the switch or from the PoE. You can have 2 cables going to the access point. Yep, if it goes over 1 gigabit, you can have it. If you think about replacing Wave 1 to Wave 2, yes, of course, that makes sense in some cases. Yep, not every time it does make sense, but it does make sense sometimes. So you can think about using 80 megahertz channel or 160 megahertz channel. You can think about multi-user MIMO. Check if your client does support it. That must be supported on both ends, client and access point. And the PoE, high PoE, is mandatory for that. So there is no vendor on the market which can deliver all features with Wave 2 with the old PoE only. Okay. Evolution from the management point of view. Completely different point of view than what I was talking till now. So from the management point of view, in the past, as I said, once upon a time, access points were standalone. Okay, so you have access point, put it here, another access point, put it there. You configure this one, you configure that one. Those access points at that time were not talking each other. So roaming was an issue. Or roaming was not an issue. Secure and fast roaming was an issue. Okay? So if you want to roam quickly in a secure way, that was not possible because those access points were not able to talk each other. Okay? So simple to deploy, absolutely. Put the access point there, put the access point there, it's it. Cost effective, yeah. If you have 10 access points, the price of 10 access points is 10 times the price of one access point. Easy. Not centralized management, definitely a huge issue at that time. The next generation which come is something like controller-based or wireless switch, if you wish. Different vendors call it a different way. So in our case, it's called controller. The controller does give you a benefit of centralized management. So you have 100, 200, 10,000 of access points, no problem at all, but you have one place where you manage it. Okay? So if you want to have a new SSID, good. Do that on one place and spread it to your wireless network. Okay? Security, definitely improved much. Roaming, definitely available because you have some control plane. So those access points are talking each other or they are talking through the controller. Okay? There are some challenges, like you need to buy the controller or access point which behaves as a controller. Okay? So you need to buy it, so there is some cost. Regarding scalability, can be good, can be issue. The third option, which is now, let's say, available, which is modern, which is available, as I said, and again, we will have a whole session regarding this, which my colleague will handle. It's a cloud management. So the idea is that you do not have a management on site, but you move the management to the cloud. General public cloud or private cloud, I don't care. So that's it. So it's much easier to deploy, and especially, for example, if you have a school. The school with 20 to 50 access points, they usually do not have a huge server room. They usually do not have skilled people to configure it. So that's a perfect example for cloud management. So from the, let's say, up-to-art, up-to-date point of view, both options are valid, absolutely. Some benefits are here, some benefits are here. So if you look at the cloud management itself, the benefit, and that's very important to understand, is that data and control stays on the access point. So you are not transferring the user traffic through the internet to some management to do some analysis or whatever. The data stays at the site. It stays at the access point. The only thing which you do, you move the management. Okay? Even the control, so access points are talking each other. If the roaming should happen, access points are talking each other. If the radio frequency should be changed, access points are talking each other. If you don't have the connectivity to the management, okay, everything works. You cannot monitor and you cannot manage. But the Wi-Fi works. So this is Wi-Fi as a service, if you wish, or cloud-based management. So some comparison, benefits, and disadvantages of cloud-based. So much easy to maintain, much easy to deploy, because everything is already in the cloud, so you just do that. On-premise, you have usually more features, more options, more control. Evolution from the security point of view, another topic. So there are many options from the security point of view, like no security. Is that the option? It is. Yeah, why not? Okay. Then we have some encryption mechanisms like wired equivalent privacy. What that means? No security at all. It's like on the wire. Okay, so if you have access to the media, you can see everything. That's the same with with the web itself. You can crack the web in a matter of seconds with the today options. WPA with the pre-shared key or WPA with 802.1x, it's also very easy to crack it today. Okay, so it should not be used. This is a funny thing. The wireless protected setup, especially if you have PIN. So instead of putting a pre-shared key to the access point or to the management system and to the client, you put their PIN. So if you are not able to put their key and you are able to put that PIN, there is something wrong with you, not with the wireless. Okay? So yeah, that's just for home office, probably. Yep, WPA2 and role-based access control. These are, in general, things which do make sense to use today from the security point of view. So WPA2 with 802.1x or with pre-shared key does make sense, definitely. Role-based access control is something which I believe is a must today. So the idea is that you have different users going to the same wireless, and each user does have maybe different VLAN, maybe different access control lists, maybe different quality of service. Okay? So I don't need to go to different access point or different SSID. And there are technical benefits of that, which we will have another session for that, talking about that today. So topology, quality of service, access controls, and VLAN, it's based on the end system who connects, not based on where you connect. So you can have one SSID, and based on who connects, you assign the role. Security, also detection mechanisms regarding the security of the wireless itself. So there can be rogue access point. There can be misconfigured access point. There can be spoofing. There can be a honeypot. So you should consider also, regarding the wireless, you should consider wireless IDS, wireless IPS. There can be a lot of attacks, and there is a cure for that. Not for everything, but there is. There is something which is called wireless IPS, not only detection, but also prevention. So you can triangulate the source of the attack. So maybe you cannot do something with the attack because someone is just jamming the air, or someone is doing some, for example, de-authentication attack or de-association attack. So the only thing which you can do, you can triangulate, find the guy, and just use the force. Okay? Or you can do mitigation. Depends on the threat which you are facing. So the evolution from the security regarding wireless IDS, wireless IPS, these solutions are available, usually combined with the wireless solution itself. Evolution in design, that's a really, really important thing. And I face it so often that when I come to the customer and customer said, yep, I would like to have access point here and here and here and here. Why do you think you need the access point there? Best practice? I guess. Yes, it can be done like that. If you want to have wireless successful, the design should be done different way. So first of all, multiple SSIDs or single SSID, or as low amount of SSIDs as possible. From the, let's say, social point of view, if you have one SSID in the air, you cannot make a mistake. Okay? If you have 10 SSIDs in the air, what the user will do if the user does have an issue? We'll try another SSID. And yes, of course, remember it. So the next time he comes to the room, the Windows computer in general, or the computer itself, will choose one of them. And then the user complains, hey, the Wi-Fi does not work. Calls to the help desk. Where you are connected? To the Wi-Fi. Which one? Oh. Now it works. Where you were connected 3 minutes ago, when it was not working? No idea. Okay? So if you have one SSID, it's easier. Technical point of view, if you broadcast an SSID, it just consumes the air. The broadcast itself goes on the lowest possible speed. So do you remember the third slide? Lowest possible speed, if you enable the 11B clients, it's 1 megabit on 2.4. On 5 gigahertz, it's the same, 1 megabit. Okay? So comparing to the speed of the user traffic, which can be 450 on 2.4, or it can be 1.3 gigabit on 5 gigahertz, it's 1,000 times slower. So each SSID which you broadcast does consume the air. And it is at 10 frames per second per SSID, per access point. Okay? And just imagine that it is not only about broadcasting, but if my phone will ask who is in the air, because of roaming, everyone must answer. So there are statistics and there are calculations. If you have something like 6 SSIDs in the air on 3 access points, the air is utilized on 30% if there is no one, just by that. Okay? So going to the single SSID just makes sense. Why I need more SSIDs? To have different VLAN? No. It's available with role-based access. To different quality of service? Again. To have different access controllers, quality of service, topology? That's not the reason. So you can go with single SSID design. Definitely a valid approach. In the past, all the design was done based on the coverage. Put the access point here, go where I have a signal, I don't have signal here, okay, put another access point there. That was the way how it was designing in the past. Today, no. Today, if you look at this room, how many of you do have at least one Wi-Fi device with you? I have 3. Okay? So, can the access point handle 300 connections at the same time? Absolutely, no problem at all. Will the throughput be adequate if I have 300 devices sharing the 54 megabits per second? Probably not. Even if I go to 450 megabits per second. Not all our devices are able to do that speed, but in general, that's not the design which we are using anymore. Okay? So what we do opposite. We do very low transmit power to influence only users which are really close to. I have seen an access point which does have a sensitivity of minus 112 dB. What that means, that access point can hear someone 3 kilometers far. Is it good or bad? It's bad. Because the access point does hear someone in completely different building talking. So okay, the air is utilized. So let's wait. That's not the case anymore. Yep, to make such access point, it's tough. You know, the hardware must be excellent. But we don't need that. Sometimes it's really counterproductive. In the past, the mobility of wireless devices was something like, yeah, I'm sitting here, I have wireless, I can chat, I can download, then I close my laptop, I go to another room, open it. So mobile computing. So I'm computing on place. Today, seamless roaming is possible because of standards which are there, because of options which are there. So you can do a phone call while you talk, while you move. For example, you can watch the YouTube or whatever you wish. In the past, the wireless survey was used as a validation of the design. Today, the wireless survey is to predict what it will be. Then you place those access points, and then you do the wireless survey again to validate that the design was good. It is much, much quicker if you want to have high density, high throughput wireless. To do the prediction, and then based on the prediction, check it if the prediction was good, and then tune it. So the design process also changed a lot. So, Something which you should not forget when you are thinking about the new wireless for enterprise. Location and triangulation. I talk about that. So the threats, clients, and also unassociated clients. So for example, that's a very nice feature today. Even if I do not connect to the wireless, my device is sending probes. Like who is in the air? Maybe there is an SSID which I should connect. So this can be captured by the wireless infrastructure. And this is used, for example, in the shopping malls when they see where people are coming. So what is the most taken, so what is the most busy path? And then on that most busy path, the advertisement will be more expensive than on the place where no one is really using. Okay? So triangulation of the clients which are not associated. So I don't need to connect to the wireless and I can be still tracked. Yep, that's it. Spectrum analysis to detect sources of interference and dynamic radio management. Definitely that's something which you should consider when you design it or when you ask someone to design the wireless for you. Microwave ovens, Bluetooth devices, they are creating issues. And you should be able to see those issues, to understand those issues. And if someone calls, hey, there's an issue, you should be able to track, there was a microwave oven operated at that time when you had the issue. Application visibility. So the wireless itself, usually you do not design the wireless or the project to have wireless just for connectivity, especially in public places. That's not the business case. You will not make money on connectivity anymore. Okay? So what is important and what is nice is to see what the users are doing. Are they watching a TV, this one or that one? So where should I put the advertisement? Regarding the weather channel, so weather forecast, are they using CNN or whatever else? Are my fans Facebook friendly or something else, Twitter or whatever? So analytics of what the user is doing and analytics of, is my wireless doing well? Is the performance, which does the user see, the quality of service, the user experience, is it good or bad? That's something which application visibility can give you. Role-based access, that's what I mentioned. I believe that that's a must today. Allow lower number of SSIDs, allow the quality of service, allows access control lists. Distributed data plane and control plane. Yeah. If you think about the access point can generate easily 1 gigabit per second. So if you have 10 access points, it can kill the 10 gigabit line. So if you send all the traffic to the controller, yep, that's the valid question. How many 10 gig ports you have on the controller? How many 40 gig ports you have on your controller? Okay? I don't need that. Access point can handle it. Centralized management, definitely. I don't want to configure 100 access points one by one. I'm not a sadomasochistic. Maybe I am, but not so much. If you have good coverage, probe suppression. So that means that I will not answer for the client which is in another room if he asks if I am in the air. Okay? So it can be much easier for roaming then. Enterprise voice. There are standards for that, which helps with roaming. So you don't need to have issues on the network. Yep. There is a cool protocol which everyone likes if he is Apple fan, which is Apple Bonjour. So you can easily send whatever you wish to another guy who is on the same wireless. Pictures, whatever. The trouble is that it uses multicast on layer 2. And that's the trouble. That's trouble from the technology point of view, and that's trouble from utilization point of view. But if you don't have Apple, there is still something which is for Android also. That's called Miracast. So that's not like, oh, we are Apple fans, so I don't care. There is the same thing for Android. So you should be able to handle it. Airtime fairness, that's the quality of service thing. which you should think about that. Radio preference, definitely to force the client to go to the 5 GHz. So that's the closing slide. I have still 15 seconds, so you have a chance to read the joke. In general, technology is available. Certification is available. The management can be easy. Security can be achieved. And know-how is available also. So if you need to design a wireless network, it's not just about to not install wire. Thank you for your time.
Спасибо большое. Это была тема эволюции беспроводных технологий и наш спикер Зденек Пала.